So, uh, yeah, let's start. Hello, people. Thank you again and welcome back. I'm Dhara Vihol, and I would like to welcome all of you on behalf of all the GDG team members, GDG Ahmedabad team members. And thank you for thank you for taking time to spare 1 hour of your Sunday. I'm sure it's going to be fantastic for you. Yeah. So yesterday we talked about art of debugging web apps with Chrome developer tools with Shreyan Mehta, and he introduced some of the best and awesome tricks of debugging like element picker, device toggle, console tab, element tab, network tabs, and it was so much in detail and wordful. Like I especially learned so much things. So today we are going to continue our sessions and learn some advanced tricks which will be shared by Shreyan Mehta. And let me introduce Shreyan Mehta, the speaker of the day. He's a senior software engineer at Simform, and he loves to play with AI and ML also. And he has also learned multiple stacks, and he's been working as a full stack developer since long time. So thank you, Shreyan, for joining us today. Before we start, would you like to say something about what we are going to cover as advanced topic of debugging with Chrome developer tools?
Sure, Dharat. Firstly, thank you for such a warm welcome. Today we are planning to cover like most focused area would be source tab and little bit also of audit tab and performance tabs. So majorly of source tab.
Okay, cool. So let us start, and yes, you can take over from here and share your screen.
Sure. All right, great. So hello everyone. Well, this is the part two of the session that we had yesterday. So those who are here for the first time, welcome, and those who are over there, so you already know how this went yesterday. All right, let's begin. So just as yesterday, our session, this is like yesterday also, I provided a brief, chart how the session will be looking, and it won't be exactly same just like yesterday, but this is for rough idea that what you could expect and rough timeline basically. So we have introduction, we just had a little bit of that. Then what knowledge is required for this session, I will cover that. Then hands-on, and then FAQ, and then we will conclude. So these slides are copied from yesterday's slides. So for the people who were not there yesterday, so as Dara, give a brief introduction of mine. So yes, I am a full stack engineer, and I'm working in Simform currently. So I've been working and I've been debugging using Chrome dev tool since quite a long time. So yeah, that's a brief about me. And going on. So again, these slides are taken from yesterday's slides because the fact still remains the same. But I will go quickly, assuming that most of you would be continuing from yesterday's session. So basically, these are some facts and some data that on an average, how much time, how much efforts, and how much money is given and is taken by debugging process overall, in not just in web but overall in the software industry. So this is the data from that. I won't spend much time on it today. We could check your yesterday's session for a little bit details. And it's again the same graph, and just to get a brief idea that 49% of it, from all the tasks that we do, is that goes in debugging. And these are the same links from which data was retrieved. All right, so that was the reason, why our debugging, why that things matter. And now let's look how our debugging skills are. All right, so for those of you which were expecting the same photo as yesterday, so I replaced that photo since our debugging skill has been improved a little bit from tomorrow's session. I mean, that is what I'm expecting. I'm not sure, but so like our debugging skill is improved, and it is now from a newbie to like a squirrel with a bazooka. So yeah. So with this, I would like to cover what prerequisite you should have for this session. So I would expect that you would be knowing little bit basics of JS, and little bit you would be familiar with the dev tool. Like if you have joined this session yesterday, then that much knowledge would be fine enough. Or in general, basics of dev tool, how, where are the elements and all that things. So that are the prerequisites. All right, moving ahead. So yeah, so this was the yesterday's objective. Today's objective is going from beginner, since we did something like we reached the beginner debugging level yesterday. Now from beginner level, we are going to the intermediate dev or intermediate programmer level in debugging. What all we would try to cover, as I just said earlier briefly, uh, like debugger and complete use of source tab. I will go through almost each and every buttons that are available in source tab, because almost most of them are quite useful. And like application tab and audit tab. And of course, we will also go through the profile tab. So before moving forward, I would like to I would like that you should know about KYE. So this is not KYC. This is not know your customers. This is know your errors, right? So before we start debugging, you should know how your errors look like, and basically, because if you don't know that, you won't be able to debug it better. And I've seen people, or when I was starting, uh, like whenever I get an error, or most of the people when they are starting, whenever they get an error, they just copy the error message and they directly Google it before just reading it for a second. So this is a sample photo I took of a regular error. So from this, the light blue, there's a word uncaught in which I had done light blue underline. So that is for showing that is that caught or uncaught exception, basically a compile time kind of error or a runtime error or an exception. Then what type of error it is? Is it a type error? Is it a like equality error or something like that? There are a few types of errors. Like I have put the link in this slide itself, the Mozilla Dev link, which contains all the list of errors which you can go through. And this is the error stack. So whenever we get, and of course before error stack, this is the error message. So we need to understand this and this both are the most important portion. And error stack would help us to know where you can locate, and basically where we need to look for the error, or where the error happened, right? Moving ahead. So precaution is better than cure. For like right now, we guys are using sanitizers and using masks because precaution is better than cure. So just like that in real life, in programming also, precaution is better than cure. So uh, in order to decrease the debugging time, first precaution that we could have is that we could introduce, or we could induce less number of errors itself. Then of course the overall debugging time will decrease. So how we can do that? So these are some standard things that we could do to basically avoid bugs or to reduce them. So things like we could use ESLint, we could use try catch, we could use test cases, or basically TDD, that is called test driven development. So we write test cases like using languages like Mocha, Chai, and like Karma and things like that. If you don't know that, that's fine. But what that happens, like I won't explain what is try catch, because I think it would be pretty much explanatory, like you guys might be knowing it. What is ESLint, or basically linting? What does that does is it does proper formatting. It shows when a method is not used and all that things. So basic things that this variable is not used or something like that. Then as I said, this test cases or TDD. So basically we write unit test cases. So Using that, what happens is, usually what practice we have, that before pushing it or before sending it to someone to test, we will do is that we'll run these test cases, these unit test cases, so which are the most the most prime features of our app, so that we can be sure that, all right, these features are working fine. Then some other things like, uh, we could use some crash analytics tool like Sentry or something, basically, which could, like Fabric or something, like which could either record the crash, or we could send some error logs to that service, so that, after something crashed, runtime, so you could just go there and you could check, all right, what happened, or, well, like if you have mixed panel or something, you could also see what happened, or you could just at least see the logs. Then things like VCS. So VCS uh, is not actually for debugging purpose, but for example, if you use Git, right? So what happens is, say you did some changes, and you got some error, and you spend like 10, 15, 20 minutes, and then you are not able to figure what the error was. And then, if you just check, whatever, like git diff or something like that, you check whatever new things you did, so from that you can, understand either that, these are the 4 line changes that I did, so obviously before that it was working. So from that we could directly get, all right, these 4 lines I just need to test. Or worst case scenario, what we can do is, what that we could just check out, and we could just delete the current changes and revert back to a last checkpoint. If it is a small changes or change in code, and we know what we have to do, then we could also do that and save time, because sometimes we assume that, all right, bug is in this module, and we go debugging it, and we go and, like, we get lost. So it's a, like, waste of time. So we could do things like that. Also, it has a feature called git bisect. I won't go in much detail of that, but if you have time, you can look into that after the session. And overall, following all the other standard practices that we use in industry. Great. So let's get hands on. All right. So I think you all would be able to see my screen. Can we just full screen on the my screen if possible? All right, great. So this is a simple to-do app. So I know most of you guys would have done a to-do app. So, and we all love to-do apps because it could cover basic concepts. So whichever language, we start learning, we do this to-do app for like, this is the first thing that we do. All right. I will just open the dev tool by pressing F12, and we are on source tab. All right. So this is the tab in which we will spend most of our time today. Before going further, I'll just have a sip of water. All right, great. So I'll just make this, big little bit, so that we could understand what is going on. But before starting, you can see over here that we have one error. So let's go and check what the error is in the console. All right. So it is saying to do's is not defined, and it's an uncaught error. So guys, uncaught errors are like runtime errors. So we should avoid having that, because that could, create undesirable outcomes in production environment, which is not good for our system or our software. So as I said, this portion would say that. Then here, this portion, it will say which type of error it is. And here is the message. So to do is not defined. So basically, it's at some place in at this line number 130 of mean.js. We are basically using some variable named to do's, which is not referenced. So on clicking on this, it will, like, the debugger tool will take us to that place. right. Also, I purposely kept this code very small, and this code is not done by me. It is done by a student of sixth semester itself, so that we don't add much complexity in the code, and it is quite simple code. So uh, I will just make it so that we could look. All right. So first of all, the are the fonts uh, visible enough, or should I increase the font size? Is it visible? Just let me know so that we could continue. All right, all right. Okay, so we'll continue. Okay, so this says to do is not defined, right? So here, as you see, we are here over here, and it has something called to dos. So this is not defined in this scope right now. But this guy who created the code, right? So he's using this, so he might have declared somewhere. So I'll just copy it and do Control F. So using Control F, we could just have this finder that we have in editor, and we could find, we could go up and down in the code. Here we have declared it once. Here we have declared. Here it is there. Here it is there. So basically, it does not seem to be a global variable, and it is just meant to be there for that specific method only. So what we can do is, we could just like this, we could also declare it as a variable and assign it. So I will open my uh, Visual Studio Code, my editor of choice currently. So I will open it, and I'll just close all other stuff. So this is the index file, and we had the issue in our main.js on line 130. All right, so here we are. So I'll just add where, and I just hit save. I'll minimize this for now, and I just hit refresh. So it didn't got refreshed. So I think it has been cached. I will I'll check if I saved it. Yes, I have saved it. I will hit Control Shift R. Yeah, I will delete this once. Yeah, okay. We also have another error that we'll look into later. So as you can see, we have solved this error that we had here. So there are around 2-3 errors that we I have kept in purpose so that we could solve that, and we could learn how to use this in the same in that interactive way. All right, I'll close this one. All right, so we have solved this error. Now before going further, uh, what are these things, these little buttons over here? I will just tell you that first before I just use it. So not in JavaScript, but almost in every programming language, we have what we call as a debugger. So a debugger is very useful tool. We like some of you might have started programming from C or C++ and would have used Turbo C++ as your compiler. You know that blue screen thing? Yeah. So even that had a debugger, which most people might not know, but even that had a debugger. So debugger is always there in most of the languages. The way of implementing it might be different, but it is there most of the time. Now we'll just describe what these buttons are. So When we have like, I will just, what I will do is, first I will add some debuggers. Like, I will add a debugger over here. To add a debugger, just do a left click on this, number of line where we want a debugger, and it will show some red dot like this. I will hit refresh. All right. So this is what debugger does. Basically, if we set a breakpoint like this, right, it stops the execution of code at that point, or at that line where we have set the breakpoint. So since we had this dot over here, our execution is stopped on this line, right? So what all we can do over here? We can do many things. First, like, for example, if I hover, like, already the list is showing like this, but I could just hover on list and get its details, like, you know what it contains. So basically it's an array of JSON, right? I will just increase font size, but it's not. Yeah, it's completely visible now. So we could hover on stuff like on variables and other data storage things, and we could get its data. What we would also do is, we could also access variable from console, because right now we are on this particular scope. We are paused on this particular scope. So we could also console that variable, or we could also do something like this. Basically, we could access this variable in real time from this scope. All right. Since we named this scope, you could also see there's a list over here which says scope, right? So as I said, it will show the scope of that particular, like here, whatever scopes like are available. So local module, global. I won't go into extreme details of this, that what are this, but you just understand for now that these are the scopes. Like, we have scopes in JavaScript, that is like global scope is the window object. We do things like alert, so that is in global scope. So just like that, we have different scopes. So this is the tab which shows that particular scope. I hope I am not going fast. I am trying to go quite slow so that each and everyone can board this ship and could understand. All right. Next is, there's a tab called watch. So I will go into this also, but there's a tab called watch. So this watch is a very interesting tag. I will just clear this all for now. So what this does is, we could, as I said, we could write variable names over here, and we could access them from here when we are, stopped at a current breakpoint. What other thing we could do is, we could add a watch. So basically, we could watch variables, we could watch expressions. Like, for example, we could watch a thing called a variable called list array, right? So list array had zero thing, like it was a null array or an empty array. Why? Because list array was initialized somewhere above, I believe, in the code. In the, like, it was like declared and initialized as a null array at the very beginning of the code, and we have not yet initialized it, right? It would be initialized after the next line. So here currently it is showing as array 0. So whatever variables that we want to watch, because every time we cannot go here and write variables, right? So we just add watches for that. So we will also add watch for, say, to dos. So it is undefined. Why it is undefined? Because we are not yet fetched it. We are on this step. So whenever we are on certain step or certain breakpoint, that code or that assignment has not yet happened. It will happen after we go to the next line, right? So uh, at that point, what all we can do is, we could check whichever parameter is being passed. In this case, it is list. So all right, so we added two watches. Now let us go to this buttons. So this button, on clicking on this button, it will resume the script execution. So basically, uh, it will, like we have paused, right? Just like our DVD player, we have paused the film over here, and on clicking this, it will play from here. So I'll just play it or resume it. So as you see, it happened. The complete execution got completed as it was supposed to. All right, I will just hit refresh so that we again can come over and our breakpoint can break on this line. All right. So again, we are at the same point. Now we know what scope would say. So I would not open scope tab because of the limited space we have on screen right now. I would keep this watch tab open. All right. We know what this button is, right? So this is covered. We won't use this much now until and unless we need to, but not for explanation purposes. Next is step over next function call. Right. I will explain these three together. Step over next function call, step into next function call, and step out of current function. So the difference between these three is, so I won't explain this one and I won't use this one because uh, most of the debugger tools that we have, for example, if you are debugging in Node JavaScript and in your, like say, Visual Studio Code, then you won't see this button in debugger. Most of the debuggers have this four thing: the play and pause, the step over, step into, step out, and of course this button will deactivate breakpoints. I will explain what this is. I mean this both is later, little bit later. So I'm not going to explain this step because it is quite similar to step into function, and you could always use step over next function call and step into next function call to eliminate the use of this. So we won't have a practice of using this. Okay, so what does step over next function call do? So basically, say for example here we would be having a function call, right? And here we have our debugger paused. So if I do step over next function call, then the debugger won't go inside the method. The debugger would skip going inside the method, although it will execute the code that is there in the method, but it will, like, it won't stop in that method. It will just go to the next line. I will also show that using some function, but this is what it does. Second is step into next function call. So consider the same scenario, right? That the debugger is paused in some function, and now we think that all right, the problem could be in the function that is being called. So we would need to check that function also. So and get paused in that also. So in case like this, we will use step into next function call. So if we are paused here and here is a method call, and if you do step into, then we will go into that function definition where it is defined, and the debugger would pause on its first line. Then we could like use this both to go step by step to the next line in that function, and the next line and the next line likewise. Similarly, this is exact opposite of this one. If we are in, like in that example, we went into that function, right? And after looking into one or two lines, we got that all right, this function is like not doing something from, like critical, and basically we figured out that the bug that we have currently that we are solving is not from that method or not that function call. So we do not need to stuck inside that function call and skip and step into each and every line and come out from that function. What you could do is you could click on this step out of current function, and we'll come back to the place where that function was called. I hope I'm making little bit sense. And if you are not understand these three things, don't worry, I will explain it in the code also. So I'll just click. I'll just show like when we don't have any method. So at that time, step over and step into, like they both will work the same. Like see how, like I will play step over, it went to next line, and step into, it will also go to the next line. But before that, you would just watch that our to dos has changed. The to dos, it shows whatever we have passed from the JSON of this, like this JSON variable list. So we have now to do as an array of length 2. Now we will do step into. So we would go and get stuck on this line. So since there was no function, as I said, this both will work similar till it's a function call. So again, you could observe list array. It didn't have anything. It was a null array. Now it is an array with length 2. All right, great. So I will just resume the code right now. All right. So to explain that functional breakpoints, what we'll do is, inside the code, we have done many method calls. Like for example, uh, what we'll do is we'll just create a function in this load itself, and we'll just call it. I will make it full screen for some time. Right? I will just make a variable which is a function, test function, and just a console log, and we'll just call it over here, that is test function. And I'll save this and minimize and just reload it once again. So as you can see, we have this test function over here. Now I will just skip this first line and the second line. Now at this time, the working of this both buttons would be different. If I do click on this, then we will go to this line and this function would be executed, but we won't get stopped in that. I'll like, so you can see the source is clear right now, right? So first let's go inside the function. So using this, we could go inside that function. So see, that function got called and our debugger stopped on the first line of that function. So we could just use any of this and check this function line by line, one line at a time. So say for example, I did this, but now I got that all right. This method just does things like console and it's nothing functional. So what I will do it, I will like to come out of this function or this method. So for that, as I said, I will use this button, that is step out of current function. So as you can see, we didn't did this line. We didn't got stopped on this line, and we went directly over to this line of code. I hope this step into and step out of current function is quite clear. I will hit refresh once again just to show whether if I click step over at this point, what it had done. I'll just okay. So here earlier we did step into function call, right? So now what we'll do is we'll do step over next function call. So it will just skip going into that, but our console will still print that, right? So that code is not skipped, just our debugger won't stop there. So I hope uh, I made this clear, and we have like taken it very slowly. I hope these four buttons are easily understood by most of you guys, because these are the most important ones. Do anyone want me to repeat that one, or should I go ahead? All right, we'll go ahead. So these four things are clear. This button, what it will do is it will deactivate the breakpoints. You could also deactivate breakpoints by just checking out this, or you could right click and deactivate or remove the breakpoint, right? Why this is useful? So when we are having a big application, sometimes we don't want to pause on that, so you could just deactivate it, just like this, right? I won't show it's working right now, because it's quite self understood and we have a lot of things to cover. All right, great. So say for example, this, so see, currently list array.length is 2, right? So this for loop will be run twice. That's clear, right? Assume that this loop is running for say 50 times, right? And after you are done your code and you got a bug reported that after 40th time the last 5 or 10 items are having some issues or are throwing some errors. So to debug that, for example, if you just put a debugger over here, what it will do is every time on every iteration it will stop. But for this, since it's just a two length, length of two array, it's fine. We could just wait for both the iterations. But if it's a big one, then we could use is we could not take this regular breakpoint, and we could create a what we call as conditional breakpoints, right? So we could do right click and add conditional breakpoint. So in this, we could add an expression. So when that expression evaluates to be true, at that point it will break, or else it won't break. For example, in our case, since I starts from 0 and it will go till the time it is I less than 2, so I will like to get it break on when I is equal to 1. So I'll do simply like I triple equal to 1, right? Here also we can just do log point or breakpoint. Log point is basically for login purpose. You want I won't show a demo of it. It's quite simple. Breakpoint, it will just become this. So we will keep it how it is, like a conditional breakpoint. Press enter. All right. So you see it shows a different logo. I will resume this processing from clicking this button. So as you can see, the first time it didn't got stopped over here, and first element or the zeroth I position, it got whatever things, like whatever method was being called and whatever processing was being done, it happened. But it stopped when I, like currently if I add I in watch, it will say I equal to 1. So at I equal to 1, since that was our conditional breakpoint, we got breaked at that. So this is what we call as conditional breakpoints. This is very helpful for when we are debugging in loops, or when we are debugging, say there are certain methods that are being called many times from different places, right? So from regular places, and from all the time we are not getting error from there, right? There is certain thing, for example, there is a variable which is having value undefined, and due to it it is breaking. So we could add a breakpoint that this variable uh, break it when it is equal to undefined, or when it is basically equal to zero. If a variable is zero and we are using it or something like that, and we are not expecting zero, something like that. So we could use at places like this, and it is extremely helpful. All right, I will just skip this, and I will also remove this breakpoint. Since we don't need this, I will also remove this breakpoint. All right, I hope the breakpoints are clear, so that I could go on to the next portions. All right. Uh, as you see, we had to change the code. Like we could change code from here, but it won't save, right? So to change code, or so we don't need to go to the editor, and we don't have to juggle between the windows. A best thing that we could do is we could add our folder in the debugger tool itself. So I could click on this double arrow, and on the file system here you could add on this add folder to workspace. It will open our file explorer where to select, and I will select this to do app, select folder. It will ask for permission. I will give it. So now we could edit our code directly from here. So this is very useful, because whenever we get some error, so directly we could change here, we could hit save, and we could refresh. So it will automatically refresh also, and it will work like magic. All right. So enough of this breakpoint thing, right? Before going to some other breakpoints, let me show you one quick tip and trick. So just bring the drawer over here by pressing escape, and just press this more tools button and click on coverage, right? Hit refresh on this to load once again. So what it does is it shows the coverage of the code that we are using, right? So for example, this bootstrap.min.css. So you can see most of the things of this file is not being used. Most of the styles that are there in this CSS, you can see the coverage is just 2.7%, right? So we are wasting this side. Like you can see here, whichever code, whichever snippet is being used currently in this portion, it will be shown as blue, and whichever is not being currently used, it will be shown as red. All right, there's one catch too, that since it does not go through all the files, it goes using the how the debugger works. Just like that, it goes using the execution flow. So sometimes it won't be 100% accurate. So by that, what do I mean is that currently these things are not being used. But say for example, if I do delete, I delete this both thing, and we have some errors, so which will solve them too. So after deleting them, we might use some, like the CSS could change, right? So this shows the coverage that is currently being covered, which is like currently we are just having 2 point or 3.4% coverage, which is very low. So for that, we could usually do, if you are using Webpack or Gulp or things like that, we could like do remove the code that is not being used, or only keep the code that is being used, so our file sizes would be reduced. I'll come back to this one. So this is a handy tool, and I'll come back to this once again when we are in the audit tab. All right, I'll just close this and ignore this red and blue bars for now. So let's solve this one together. This says cannot read property parent element of undefined. So this is HTML button element dot remove. So we'll just quickly see our debugging skills that we learned using debugger. So here uh, I put a debugger and I will add delete. So this right now I could also add expression over here like this. I could add it is undefined this dot parent element it is not available, and that's the error that you are getting, right? What's the error that you are getting? Cannot read property parent element of undefined, because this was not defined over here, right? So what you can do is you could check where this method is being added. So basically it's an event listener, and we could expect that it would show the which element basically called, you know, that method. So since we have added a file to here, what I'll do is I will add a element for event and hit save, and just do this once again. So right now we have the event object also, right? It's a basically a simple click element, like click event listener. So it will give things for that. So we will solve this together in the end. I would like that someone from the audience who is watching this, if they could answer it would be a simple bug. So if someone from them could answer that, so I will just stop debugging from here, and if you can figure that out, I will put it like this. You could take a screenshot of this also if you want. You will easily get from these things that are visible over here and from this point that what we want, right? I won't solve it right now. This way you could test whatever you have learned till now. Okay, moving forward, we have this XHR fetch breakpoints, right? So what are this for? So basically, whenever we have some API calling, right? So uh, we could, as we saw that yesterday, you would be having that over here, right? We could observe it from network tab, that's for sure. But what if we want to check that what payloads or what request headers we are passing to that particular AJAX call, or what are we getting from that response? Or basically, say if the project is not yours, like most of the time when we are working for big companies, we are working on maintenance projects, and most of the time, like quite like I mean around 70% of the time, the code that you are debugging, that is not written by you, so you might not even know from where the API is getting called. So say you got from the network tab that all right, the issue is from client side itself, and I am the like we are the one which are sending wrong data to API. That's why the issue or the bug is there. So, but you don't know from where that API is being called. So, just to test that, what I will do is I have created a simple like dummy Node.js API just to demonstrate this. Right. I have also put it somewhere over here. I will copy this, and I will put this in our this load method so that we don't need to go to any other place. I'll paste this. I'll hit save. All right, yeah, we cannot use await without it being in a sync function. So we could we have this in the clear list. So I'll add a breakpoint over here because I think the clear list method is being called from this button, and I am right. So now, as you can see, when we will call this method, we will eventually call an API. So I'll clear all this and just I'll resume it once so that we could check that in network. So as you can see, we had made a simple API call. Who like I will close this also. It's a simple post API, right? Whose name is also post because it's simple, and it has some response headers and request headers, and basically we are not sending in anything, right? It's a dummy API. But say for example, this was the API and we are the response is also dummy. It doesn't make any sense. But if we want to break on this API and we do not know that the like currently we know that this API is being called from this API. So we could put a debugger over here. But what if we don't know where this API is, right? So in that case, we could use XHR or fetch breakpoints. So how we can use that, I will show. We could copy this. We could basically also add a regex for that, but I won't add a regex right now. So break when URL contains this. So whichever XHR request that we do, that URL, if that contains post, it will break on that. So let's click it once again. So see, it broke on this, right? We didn't made like this API call is old one, and we didn't make any new API call. So before the call happened, it got breaked. So it is this portion. This file, we do not know what this file is, right? So for this also, I have a tip and trick. So say for example, you can go from spread.js where it was called, you can go to exports and this was the async block, right? So we are fortunate that we are not using any framework. So that's why we just have this small call stack, right? And in the last one, we could just click on this and get okay. So it was called from main.js 121. But if the call stack was quite big, then it would have been quite ridiculously impossible for us to debug. So another tip and trick for that, we could use blackboxing scripts. So for example, thing like this, like api.service.js and spread.js, right? We could go on settings, we could go on black boxing, and inside that, currently I don't have any black box pattern. I will go here. We could also add regex over here. api.service.js. I will, we could select black box or disable. I will add this pattern api.service.js and also which was the other file, spread.js, right? So I will also blacklist spread.js. So I will hit refresh, and I mean not refresh, but I'll just replayed the that thing, and once again we'll do. Now we'll see how our call stack looks, and I'll also clear all these breakpoints for now, right? We just have this XHR breakpoint. So on clicking clear to do list, this we got broken at this point. But now just look at our call stack, right? This is so small. We do not have things like api.service, we do not have spread.js because that were the ones which are like kind of wrapper methods, and Once you will start using some frameworks like React, Vue, Angular, no matter any front-end framework, then there will be many wrapper methods from which the API will go, right? So what that are not the ones which would be probably having errors, right? Most probably the error would be the place where it is being called. So we just left with this one. I hope we got what we did in the black boxing thing. We got our call stack shorter. So here, in fact, we could do step out of function, and of course, we could also add Grammarly in this. I'm not using it right now. Okay, it got a little bit. I'll just hit refresh. So currently, since we are streaming, and my PC is like at a very bad state, that process got hanged because that Grammarly JS file was quite big. And yesterday also someone mentioned. So sometimes when the scripts are quite big, we get a error message over here somewhere in between saying debugger out of memory. So that happens, but it is not that usual, right? It is very occasional. So I think you got the gist what we did with XSR breakpoints. I'll check this out. All right, great. Now let's go towards the next section. We see what call stack is, right? In the API section, we see what breakpoints are. We saw what XSR fetch and breakpoints are. Now it's time for DOM breakpoints. So what are they? For that, I will go back to the elements tab that we just saw yesterday. So just say for example, uh, I'll just do add to list first, right? So we have this element. Now say when we are adding an element in this, right? Currently, when I will do add to list, a li element would be added in this ul, right? We all know what ul and li are, right? Like it's unordered list and it's that list item for that particular list. So if I don't know which function is being called or what is actually happening, what I could do is for this ul element, I could right click on this, and there are three types of DOM breakpoints. One is subtree modification, second is attribute modification, and third is node removal. I will explain all three of this. So subtree modification, what that basically means is when something inside that is changed, right? If an element inside this ul is removed, is edited, or something happens, then this breakpoint gets triggered. Attribute modification, like modification, when any attribute of this particular ul tag, for example, if we change some class, if we change some data id, if we change some z index or anything, at that time this breakpoint gets called. And the last one is, of course, on node removal. So when we hit delete, right? So currently I will do is on subtree modification. So we have this breakpoint. That is the same breakpoint. And yesterday I skipped these two tabs. So this is that tab that is we are using right now, DOM breakpoints, and it is also visible in here. So it's present in multiple places. It's basically redundant and it is available in multiple tabs. So now when I do add to list, it should ideally break, right? And it break where it got broken at this point. So it shows us that where we are changing this subtree, the ul, it is happening over here because we are appending a js or dom element to this UL. That would be basically another element like this with two buttons and a text which would be DFG, right? I think I am making myself quite clear. So using this, we could use DOM breakpoints when we don't know when the DOM is getting modified. This is especially helpful when we have multiple third-party libraries which are changing our DOM. All right, I just like resume this. Right, I won't go into much details. Like we saw how subtree modification works, right? Similarly, if I will just remove this breakpoint. Similarly, if we right now we have an error in delete which I have kept for the audience right now. So we could also do things like I will do right click and like subtree modification for this. So when this is being removed, then also it will be hit. And for this, it will be, for example, if I delete this element, so for this UL, it would be subtree modification event. And for this, it would be a node removal event because this node is being removed and this subtree is being changed, right? I won't go into details because of the time constraint. All right. So that were the three types of DOM breakpoints. These are also very useful on, as I said, third-party APIs and calls. I'll remove this also. Going ahead, we have these two other things, global listeners and event listeners breakpoints. So what are they? So global listeners, basically it will list all the listeners that are being added globally. Like say for example, if we have some click listeners, or right now we are having load listener, right? That on load on window.load, this is being called over 130 line, right? Window.load. So this is an event. Then we are also adding events like using add listener and things like that, but that are not globally. This is for global listeners. Going ahead, so this will just show us all the events on the main document, or on the window, or the navigator objects, things like that. Then the last tab over here. So after this, the source tab is pretty much finished. So is our time going too soon. This last tab is event listeners breakpoint. So say if you don't know where on clicking this button what is happening, right? This is the visible change we had that, all right, this will get clear. So another way is what we could do is we know that something is happening on click of this button. So what I'll do is I will set a click listener breakpoint for mouse for click, right? And it will break on this click. So I'll click this button. So this onload file is the place where it is being called. So this is actually an extension, so we don't need this. But what you could do is you could also add this in black box. What was the file? Onload wff.js. Right. So I'll just resume this. I had to hit a reload, unfortunately. So let's do this once again. I'll click on this button. We have a mouse click event listener set. On clicking this, so these are the files. We could always hide these files, or what we could do is we could do like step out of function. So on stepping out, we see that all right, here this is the method that got called on click of this. So basically this method was assigned as a click listener for this particular element, right? So this way we could understand that. I will uh, so basically this is happening due to all the extensions that I have. Apologies for that. Next time I should have removed the extension before the session, or I might use some incognito window for that. All right. So our source tab is pretty much covered. We have covered everything from this except this small little button and this small little button. So I'll just quickly say what that are. So when I have this thing pause on exceptions, so for exceptions that are like runtime errors, it will pause. So basically any error that is either not handled or cached or it happens on runtime. So that would be like we our debugger would pause there if this button is clicked. So even for testers, this is very useful. If you are testing for some site which is being developed and you are finding bugs for it, you can keep this on so that you could report bugs to your developers for uncaught exceptions also. All right, and this thing is for the case when we have minified files like minified CSS, JS, all that thing. So we could format it from here. All right, great. So we have covered the source tab, but I think we have crossed the hour mark. So I will go to audit and the performance tab very quickly. I won't spend much time in that. So for when you want to do audit, I would recommend you do it from incognito window, since what happens is the extensions that we have added, it affects the auditing a lot. So it's recommended to do on incognito window. In fact, many times that audit breaks in regular window. So you might think, where is the audit tab? So in recent versions, audit tab is renamed to Lighthouse. Right, so this is the audit tab. Best part about this is you don't need to do anything by yourself. Everything it shows report, a detailed report by itself. So just click that button and it will generate a report. In the meantime, I will just have a sip of water. All right. So as you can see, it has analyzed our site and the performance is very good. The accessibility is very good. Best practices are very good. SEO is fine. And it's not a PW or progressive web app, so it's null. All right. So it will give a detailed report. Right. Here you can view the trace. So we'll come to this when we go in the profile tab, right? Come back to the Lighthouse tab. All right. So we are ignoring this button for now for just few minutes. Here it will show the screenshots, in certain delays so that you could know what is happening. Here we just have a this box, small yellow box. So the screenshots would look similar throughout, but for big sites it will be drastically different. And we are just currently looking into performance. We'll also look for accessibility separately, and other tabs also for like best practices. And also scrolling this through, you will see reports like this: opportunities, diagnostics. For example, we have this thing, remove unused CSS. So it is showing that my bootstrap.min.js is unused. So currently it is not being used properly, and it is saying unused. So as you can see, these buttons over here are using the class of bootstrap, but it is still showing it is unused. Why? Because it is just using 5 KB of that. So here the difference also, it will show that size, current size is 195 KB and potential savings is 190 KB. That's because if you remember, I will just go in this and look to a bootstrap like menu. And also if you remember our coverage section, when we did coverage, uh, this shows, right, most of the part is unused, like this. I will just make it small. Most of the portion is red, right? Only 2.4% is covered. So that's the reason. And you could see how much that evaluates to in kilobytes. So the used person, that 2.4 is basically a 5 KB thing, and we are importing a 190 KB file. So using coverage and all that things, what we could do is we could copy just the required classes and take that into our main.css or the CSS file that we are optimally using. Or of course, what we can do is use something called webpack or grunt or gulp that would do it. It will make you do it by themselves only. You won't need to do anything manually. Also, there are many tools, third party tools. All right, I won't go into much details of it because the report is very detailed by itself only. All right, so this is how we can use the audit tab. So see, I'll just show what happens. For example, I'll just comment this CSS over here in the HTML where we are calling it, just for the time being, so that we could know that okay, the audit is happening appropriately, right? That error should not come now. The site could load 2 or 3 times while it is being audited. That is absolutely fine, nothing to worry about. So see, you can see that the that error or the that red line, that is now not there. So basically that gets reflected. I just wanted to show that. I'll just save this and make it how it was. All right. I'll also now go to the performance menu. I will clear this. I will hit record to start a new recording. Or basically, this is the profiling, or it will show us the performance of this site. So, for example, if you have certain methods which are taking long time, certain libraries which are taking long time to download, or certain method in the call stack is taking a lot of time, so all of that would be shown here. Your rendering time, your repainting time, everything. So that's the reason we have kept this tabs in the advanced section of debugging, because most of the time you would be working in service projects and in projects where you don't need this much of calibration. So this is extreme calibration. Your site would be very much calibrated. I was just taking too much of time. Just a second. I will go from here. I'll stop this because we are already over an hour, and I know it's a Sunday. So okay, so I stopped. So this profiling is not completed, but this is how it will look somehow. You will get pie chart over here. This is just for a few seconds, so this is an incomplete data, but you get the gist. You will get the screenshots according to the millisecond timestamps. You will get which are frames are being rendered, these GPU usage, the thread memory, everything, each and every detail you would be able to see over here when you let this happen completely. So I think Tara, we are well over an hour. I think we should conclude this. Those these things you can explore. Even if I say right now, people might forgot that. So Dara, are we over an hour or something? Yes,
So,
we are.
yeah. So, thank you, Shreyan. This was really informative session. I bet it was also for all the our audience. So let's quickly wrap up our next question answer round. We have some
Sure.
questions from yeah. So the first question is like, what would you prefer for debugging? Like when you showed that you use VS Code, so there are multiple debugging tools and add-ons available for browsers and also your coding environment. So which one is better? Is it like uh, browser is better, or when would you like to use any extension in your environment?
All right. So it depends on the usage, but broadly I could say is when I'm working on front end. So at that time I like to debug from browser because we need to see the CSS and HTML. So we had the code, and I prefer a multi-screen distribution. So it is good for me. In one place I could have a debugger, and other the screen. And for things like Node.js or stuff, I like to have it in the editor itself.
Okay, cool. Yeah. So the other one is like when you showed that there are multiple errors and issues, and you have to face everything in debugging. So when you use TypeScript instead of JavaScript, is there any advantages like you have to less debug and you will have more time to work on your code and everything else?
Right, right. So yeah, definitely. I am a huge fan of TypeScript. So in TypeScript, most of the we don't get runtime exceptions, right? That we would get in JavaScript because it is tightly coded. And if you are, say, for example, using some method or calling some method that is not being declared or that is out of scope or something like that, it will fail in the build time. For example, we are using some React application, right? So the error would come at the time you will build the React app. So it is better to have it rather than having runtime exceptions.
Okay. So, as you mentioned, using React, so we all know that how the error messages are displayed when you are using React or native. It's
Right,
a
right,
little bit less self-explanatory. So, how
right.
would you prefer to debug all those errors?
So for React or Vue, so basically it becomes a little bit more complicated than vanilla JavaScript or things like that. So for that we have like most of the developers who are using React. So we use extension for React also. In that we could see the I forgot the word. We cannot see the Redux store and things directly from the browser at that point. In React Native, we can, I believe, but in React, we could see the states and props, I guess. So from there, we have two debugging module for that. We could different tabs, and from there we could have components and for pages like also we have. So from there we could do that, not using the regular thing, but we could also use that, but not that extensively.
Okay. Yeah. Thank you for your answer, Shayan. That was really helpful. And yes, so thank you for being with us and insightful sessions. I hope you guys all enjoyed this session. Yeah. So thank you for being with us.
Thank, thank you so much. Thank you so much. Thank you so much. Complete GDG team, Paresh Bhai, Jumil Bhai, Hiren sir, Dhruva, everyone, each and everyone of GDG team, Nara itself. Thank you so much for having me here and to let me give my 2 cents.
Okay. So we have just a single one more question. If we have, can you answer that one too? Mayur
Sure.
asked that how to increase speed. So
Uh, yeah. So as far as I'm understanding, it is referring to speed of sight. So for increasing speed of sight, for example, we used auditing or like Lighthouse. So it will show whatever like resource blocking things we have, whatever things are there which is taking much CPU, then whatever thing is taking much of resources. So using that we would to like tweak and do things like this, like we would optimize our images, We could use, say for example, if you are using any image, then we use source set, which basically we provide multiple image URLs, and it takes it by self whichever size is required according to the window. And there are many techniques for image, optimizing your image. So things like that we could do, and
Okay.
Lighthouse can help definitely.
Yeah, yeah, that's right. So I hope that answers your question, Mayur. And yeah, so that's all from our side. Once again, thank you for joining us on Sunday and giving 1 hour, your precious 1 hour. I hope that it was worthful. Yeah. So thank you so much.
Okay. Thank you so much. Yeah, bye bye.
Bye.